Hello all. In today's session, we are going to discuss about poles and zeros of function. In this topic, we will take closed loop transfer function, which is equal to C of S divided by R of S. C of S is nothing but output of the system. R of S is the input of the system. The knowledge of input signal is required to predict the response of the system. In most of the systems, input signals are not known, and it is ahead of time. The characteristics of the input signals are of four types. First one is a sudden shock. It can be a sudden change, a constant velocity, a constant acceleration. We know that standard test signals. We have discussed those test signals in the previous class. We'll also see that in this period. First one, the step signal, which equation is A when the time is greater than or equal to 0. Second one is the ramp signal, for which R of t is equal to A into t for t greater than or equal to 0. And the third one is a parabolic signal. The equation of that is R of t is equal to AT square divided by 2. Fourth one is impulse signal, for which R of t is equal to 0 and this impulse signal has which has large magnitude available for a very short duration. So it is called impulse signal. Now the poles and zeros of the function is the next topic. If the given g of s is equal to s plus 6 divided by s plus 3 into s plus 7, then the poles are s equal to minus 3 and minus 7, as we discussed in the previous class. Poles are the components which is available at the denominator of the given function, given polynomial. Zeros are the values available in the numerator of the given polynomial. So there are two poles, which is s equal to minus 3 and minus 7, and 1 0, which is at the top, in the numerator. Likewise, the poles and zeros varies for different system. Now this denotes the poles and zeros. If you want to discuss the type and order of the system, suppose the given function is s plus 3 divided by s into s plus 6 into s plus 4. Now, since we have only one s separately, the type of the system is 1. What is the order? It is equal to 3, because in the denominator we have s cube as the maximum value of s, so order is equal to 3, but the type is 1. The next example is 1 by s into s plus 2. Here only one s is available exclusively, so type is 1, but the order is 2, because if you multiply that s into the make it as a common function, it becomes s square, so order is 2. Likewise, you can decide the type and order of the system. If there is no separate s in the denominator, you can mark the type as 0. We have taken the fourth example, s divided by s plus 6, since we don't have s equal to 0 value, so here type is 0, but the order is 1. Now let us see what is the response of first order system when the unit step input is applied. This we have discussed in the previous class, but we will see to that again, so that you will have a deeper understanding of this topic. What we have taken is the input is R of s, output is C of s. The gain which is available for the given system is 1 divided by st, which is s, the first order system. Okay, now the feedback applied is 1, that is equal to 1. So the closed loop transfer function formula is C of s divided by R of s equal to g of s divided by 1 plus g of s into h of s. So I am substituting g of s equal to 1 by t here. It becomes 1 by st divided by 1 plus 1 by st into 1. Feedback is 1. Mathematically, I am changing the values here and there. So finally, the answer which I got is C of s divided by R of s equal to 1 divided by 1 plus st. Taking out t as common from the denominator, it becomes 1 by t into s plus 1 by t. So taking that 1 by t into the numerator becomes 1 divided by t whole divided by s plus 1 by t. Okay. Now I am going to see the response of this first order system for unit step. So I am applying R of t equal to 1. If R of t is equal to 1, taking Laplace transform, R of s is equal to 1 by s. So substituting this 1 by s in the given equation, it becomes C of s equal to 1 by s into 1 divided by t divided by s plus 1 by t. This is your final value. Now we cannot take Laplace inverse of this particular equation, since it is of this is of no form with related to the Laplace inverse Laplace transform formula. So what I am doing is I am going to take partial fraction. Since there is only two terms in the given function, I am dividing the whole term into two terms, a by s plus b divided by s plus 1 by t. So using partial fraction, I am finding the values of a and b. Here a is equal to 1 and b equal to minus 1. Substituting that, we will get c of s equal to 1 divided by s minus 1 divided by s plus 1 by t. Now we can take the Laplace inverse of given function. So taking Laplace inverse, c of t is equal to 1 minus e power minus 1 by t into t. Here the capital T denotes time constant. C of t is your output with respect to time. Capital T is time constant. In certain problems, we will be asked to find the time constant of the given system with C of t given, and the time t, small t, will also be given, which is time. Okay. Now plotting the output response for the given system. When we give input as step input, the output is like this. It increases like this. Okay. Now the starting period is called the transient period. The starting period is called the transient response of the system, where the input changes from one state to another. Now, when the state reaches infinity, it becomes steady state response. These are the two periods in the given response of the system. Okay. Now let us see a problem related to that. Let me take this problem number 1. The thermometer requires 1 minute to indicate 98% of the response to a step input, assuming thermometer to be the first order system. Now it is clearly mentioned as first order system, so we can take the equation which we have solved in the previous topic. So C of t equal to 1 minus e power minus t by t is your response of the system, in which the response percentage is given as 98%. So C of t is equal to 98%. If C of t equal to 98%, it can be written as 0.98, and the small t is given as 1 minute. It takes 1 minute. So t is equal to 1 minute, which is equal to 60 seconds. Substituting these two terms in the formula, the response formula, C of t equal to 1 minus e power minus t by t, we have to find the time constant alone, I mean capital T. Okay, now substitute it, we will get the equation like this: 0.98 equal to 1 minus e power minus 60 divided by capital T. Okay, now bringing this 1 to the left side, it becomes e power minus 60 divided by capital T equal to 1 minus 0.8, which is equal to 0.02. If you want to cancel out this e, I would take ln. So taking out ln on both the sides, it becomes minus 60 by t equal to ln of 0.02, which is equal to 3.91. You just make it out in your calculator, you will get the same answer, I guess. Okay, now t is equal to 60 divided by 3.91, which is equal to 15.33 seconds. This is your output time constant. Your time constant, see, it is also in seconds. The time constant is not equal to the small t. Okay, these two are various parameters in the given system. We have also seen the analysis of second order system. In the analysis of second order system, we have a general form, which is C of s divided by R of s equal to omega n square divided by s square plus 2 zeta omega ns plus omega n square. Okay, this is your standard form of second order system, in which the denominator s square plus 2 zeta omega ns plus omega n square equal to 0 is your characteristic equation. In this equation, zeta damping factor is the main factor, because without damping factor, your oscillations will not damp out. Okay. Now getting the equation solved, I get S1 S2s minus zeta omega n plus or minus omega n into zeta square minus 1. So this is the solution for the characteristic equation, from which we are going to decide whether it is overdamped, underdamped or undamped system or not. Okay, we have discussed everything in the previous class. So the system is classified into 4 types. First one is undamped system, where zeta is equal to 0. Second one is your overdamped system, which is zeta greater than 1. If zeta is Between 0 to 1, it is under damped. It is equal to 1, it is critically damped. These are the 4 systems in second order. Hope you understand this topic. Thank you.